Quantum communication satellites, once a concept only imaginable in science fiction, have now become a reality, revolutionizing global communication systems. Enter the era of quantum revolution, a groundbreaking shift that is redefining the way we perceive and understand communication. This isn't your everyday tech upgrade. We're talking about a seismic shift in the communication paradigm. Quantum communication satellites are not just a step, but a giant leap forward in our pursuit of secure, fast, and efficient data transmission. Imagine, if you will, a world where your data is almost invincible, where hackers are left scratching their heads, and where the speed of information flow is faster than ever before. That's the promise of quantum communication satellites. They harness the power of quantum mechanics, the science of the very small, to achieve this feat. We've seen China launch the world's first quantum communication satellites, setting a new benchmark for ultra-secure data transmission. No longer is our information at the mercy of meddling hands. The quantum revolution has brought us a level of security and speed that was once the stuff of dreams. What does this mean for global communication systems? It's a game changer. The old rules no longer apply. The quantum revolution is rewriting the playbook, creating a whole new field of play. It's not just about faster emails or more secure bank transactions. It's about a world where data can be sent from one point to another with an unprecedented level of security and speed, where the potential applications are as vast as our imagination allows. The quantum revolution isn't just coming, it's here, and it's transforming everything in its path. The potential of ultra-secure data transmission is just the tip of the iceberg. The quantum revolution is challenging us to rethink, reimagine, and reinvent. Now let's dive deep into the top 10 breakthroughs in this exciting field. The journey began in 2016 with China's launch of the world's first quantum communication satellite. This monumental event, a pioneering step into the uncharted territories of quantum communication, was nothing short of a revolutionary breakthrough. China's Mikius satellite, named after an ancient Chinese philosopher, took to the skies, carrying with it the hopes and dreams of a new world. A world where communication transcends the boundaries of traditional methods, paving the way for ultra-secure data transmission. The launch of Mikius was a game changer. It marked the genesis of quantum communication, an era where information could be transferred over great distances with unprecedented security. The satellite used quantum key distribution, a method that uses quantum mechanics to securely distribute cryptographic keys. This meant that any attempt to intercept these keys would be detectable, making eavesdropping virtually impossible. This watershed moment in technology was not just about secure communication. It was an affirmation of the potential of quantum physics, a field often considered to be more theoretical than practical. Mikius demonstrated that quantum physics could have real-world applications that could transform our lives. But the journey didn't stop there. The launch of Mikius was merely the first step. It set the stage for a series of breakthroughs that would continue to revolutionize the way we communicate. Each subsequent breakthrough, built on the foundation laid by Mikius, pushed the boundaries of what was possible even further. This marked the beginning of a new era in communication. The era of quantum communication had dawned, and there was no turning back. Following this monumental first step, the subsequent breakthroughs came in quick succession. Breakthrough 2 came about when China launched the world's first quantum communication satellite, Mikius, in August 2025. Named after an ancient Chinese philosopher, Mikius transformed the world of quantum communication. The satellite enabled ultra-secure data transmission, revolutionizing global communication systems. It was a giant leap forward, and the world watched in awe as this new frontier of technology unfolded before their eyes. Not long after, the third breakthrough emerged. Scientists discovered a way to successfully entangle photons in space, a feat previously thought impossible. This breakthrough was significant as it opened the door to quantum key distribution, a method of communication that is virtually unbreakable. This was not just about sending messages, it was about sending them securely and confidentially. It was about creating a world where data breaches and cyber threats were things of the past. The fourth breakthrough saw the development of quantum teleportation. Now, this isn't teleportation as we know it from science fiction. This is about the teleportation of information. Scientists managed to teleport quantum information over 1,000 kilometers, smashing the previous record. This was a game changer. It meant that quantum information could be sent over long distances, paving the way for a global quantum internet. The possibilities seemed endless. Then, the fifth breakthrough took place. It was the successful launch of a quantum communication network. This network connected multiple cities across hundreds of kilometers using both ground-based quantum communication and satellite-based communication. It was a significant development because it demonstrated that quantum communication could be integrated into existing infrastructure. It was a practical step forward, bringing the world a little closer to a quantum future. Each of these breakthroughs was a building block, a step forward on the path towards a quantum future. They were significant not just for their technological advancements, but also for what they represented. They represented progress, the relentless pursuit of knowledge, and the audacity to dream big. They showed us that the quantum future was not just a distant dream, but a reality within our grasp. Each of these breakthroughs brought us closer to the quantum future we live in today. As the technology matured, the breakthroughs became even more groundbreaking. Breakthrough 6 is a testament to this evolution. This advancement was all about the integration of quantum key distribution in existing communication infrastructure. It was a significant step towards making quantum communication more accessible and usable in everyday life. By integrating quantum key distribution, or QKD, with existing telecom networks, scientists were able to achieve ultra-secure data transmission over existing infrastructure. This meant that we didn't have to build new networks from scratch, but could utilize what we already had in place, an efficient and practical approach. Moving on to Breakthrough 7, the development of fault-tolerant quantum repeaters. Now, this may sound a bit technical, but it's actually quite straightforward. In any form of communication, the signal weakens as it travels longer distances. This is especially true for quantum signals, which can be easily disturbed. Quantum repeaters essentially strengthen and renew these signals, allowing them to travel longer distances without losing their quantum properties. The development of fault-tolerant quantum repeaters was a game changer. It meant that quantum signals could be sent over much greater distances, making global quantum communication a real possibility. Last but not least, the 8th breakthrough revolutionized the way we perceive quantum communication. This breakthrough was the realization of satellite-to-ground quantum teleportation. The term teleportation here doesn't refer to the kind of teleportation you might see in science fiction movies. Instead, it's about transmitting the state of a quantum particle from one place to another without any physical movement. In this case, scientists were able to teleport the quantum state of a particle from a satellite in space to a ground station on Earth. This was a monumental achievement. It meant that quantum communication was not only possible on Earth, but could be extended to space as well. To put these advancements into perspective, imagine a world where data transmission is not only ultra-secure, but also incredibly efficient. A world where global communication systems are interconnected through quantum channels, ensuring the highest level of security. And imagine being able to extend this level of communication to space, opening up endless possibilities for exploration and discovery. These developments paved the way for the quantum communication as we know it today. The integration of QKD into existing infrastructure, the creation of fault-tolerant quantum repeaters, and the realization of satellite-to-ground quantum teleportation have all played a crucial role in shaping the quantum communication landscape. As we delve deeper into the quantum realm, these breakthroughs continue to inspire and guide us, pushing the boundaries of what is possible in quantum communication. The final steps in this journey were perhaps the most exhilarating. Breakthrough number 9 is a testament to the power of international collaboration. As we know, quantum communication is all about security and data transmission. But the 9th breakthrough takes this a step further, focusing not just on secure transmission, but on transmission speed. This is where the quantum internet comes into play. Developed in partnership by China and the European Union, the quantum internet uses quantum communication satellites to deliver data at speeds unimaginable a few years ago. We're talking about the possibility of downloading an entire library's worth of books in a blink of an eye. This breakthrough not only broadens the scope of quantum communication, but also opens up a world of possibilities for future technologies. The final breakthrough, number 10, is perhaps the most fascinating. While the previous breakthroughs focused on data transmission and security, the 10th breakthrough revolutionizes the very nature of global communication systems. Enter the quantum key distribution, or QKD. The QKD allows for the creation of ultra-secure communication channels. These channels are virtually unhackable thanks to the principles of quantum mechanics. If a third party tries to intercept the communication, both the sender and receiver would know immediately. The QKD system, therefore, ensures complete privacy and security in communications, a critical need in our increasingly interconnected world. But the true beauty of QKD lies not just in its security. It lies in its potential to democratize communication. With QKD, everyone, from multinational corporations to ordinary citizens, can have access to secure, private communication channels. This breakthrough, therefore, has the potential to revolutionize not just technology, but society itself. As we reflect on these final two breakthroughs, it's clear that the journey of quantum communication is far from over. Each breakthrough, each step forward, only opens up more doors, more possibilities for what we can achieve. These mark the zenith of quantum communication satellite technology. In the span of less than a decade, quantum communication satellites have radically transformed how we communicate. Quantum communication, once a far-off dream, is now firmly grounded in reality. It's a vibrant testament to the power of human ingenuity and our unyielding drive to push the boundaries of what's possible. These satellites, orbiting high above us, have unlocked a new era of ultra-secure data transmission. They leverage the principles of quantum physics, specifically quantum entanglement, to create connections that are incredibly resistant to eavesdropping. This has given us a level of security in our communications that was previously unthinkable. But the current state of quantum communication is just the beginning. The potential for future applications is staggering. We're looking at a future where quantum networks could span the globe, creating a web of highly secure communication channels that can withstand even the most sophisticated cyber threats. Consider the impact on industries requiring high-security data transmission, such as financial institutions or defense organizations. With quantum communication, these sectors could operate with an unprecedented level of confidence in the security of their data. But it's not just about security. Quantum communication could also revolutionize the speed of data transfer. Imagine downloading an entire season of your favorite show in the blink of an eye. It sounds like science fiction, but with quantum communication, it could soon be science fact. And let's not forget the potential for scientific discovery. Quantum communication satellites could enable new forms of research in quantum physics, giving us deeper insights into the fundamental workings of the universe. The quantum future is bright, and it's coming at us faster than we could have ever imagined. It's a future where communication is not just about connecting people. It's about connecting us in ways that are secure, fast, and open up new avenues of exploration and discovery. As we venture further into the quantum future, who knows what possibilities await us? From the first quantum satellite launch to the latest breakthrough, we've seen a dazzling array of advancements. We embarked on a journey that took us from China's pioneering leap into the quantum domain to the ultra-secure data transmission it has enabled. We explored the top 10 breakthroughs, each one a testament to human ingenuity and the relentless pursuit of knowledge. We delved into the astounding capabilities of quantum communication satellites, from their groundbreaking inception to their remarkable evolution. We saw how they've revolutionized global communication systems, paving the way for a future where information security is no longer a concern but a guarantee. These breakthroughs aren't just milestones in quantum communication. They're stepping stones towards a future where quantum technology is commonplace. A future where our communication systems are not just secure, but unbreachable. In the realm of quantum communication, we can only expect the unexpected. Stay tuned for more exciting updates in this revolutionary field. Before we conclude, we invite you to be a part of this exciting quantum journey. If you've learned something new from this video, if you've been fascinated by the mind-bending reality of quantum communication, then don't keep it to yourself. Hit that like button and let us know your thoughts in the comments section. We love hearing from you. Your questions, your insights, they all add to the richness of this conversation. And remember, knowledge is most powerful when it is shared. So go ahead, share this video with your friends and family. Let them in on the quantum revolution. And if you haven't already, make sure to hit that subscribe button. Stay with us as we continue to explore the fascinating world of quantum communication. As we've seen today, the future of communication is not just secure, it's quantum secure. And you don't want to miss a thing.